All right, today we're going to be talking about geometric sequences. Okay, so we're going to go through these guided notes. So what are sequences? Sequences are a string of objects that follow a pattern. Okay, a string of objects that follow a pattern. So let's look at our first sequence. So our first term, our first had 1 dot. After a minute, we had 3 dots. After 2 minutes, we had 9 dots. And after 3 minutes, we had 27 dots. So what are the terms in this sequence? 1, 3, 9, and 27. So just like we did with arithmetic, we need to find the change. So I look 1 to 3, what did I do? Well, I added 2, or I multiplied by 3. So let's test my theory. If I add 2 to 3, do I get 9? No, but if I multiply that, I do. Okay, same thing if I go 9 to 27. So how would you find the next term? Multiply by 3. Okay, so let's look at another object. So here I have 40, then I have 20, then I have 10. Okay, what are the terms of the sequence? 40, 20, 10. How could you find that term? All right, actually it's 2 ways. You all know this. You can either divide by 2 or multiply by half. Okay? And then our last sequence, we have 3, 6, 12, and 24. How did you find the next term? Obviously, multiply by 2. Okay? So, in an arithmetic sequence, we said we used addition and subtraction. In a geometric sequence, we use multiplication and division. So what is a geometric sequence? It's a sequence where each term is found by multiplying the previous term by a constant called the common ratio. So, a sequence that is found by multiplying the previous term by a constant called the, you need to know this, common ratio. Okay, what is a common ratio? A constant that is multiplied by each term. Okay, so in arithmetic sequences, we used a common difference. In geometric, we're going to use a common ratio. Okay, so let's look at a problem that we're going through and see if we can figure some of the information out. Samantha's dad gives her a push on the swing. At her highest, she is 5 feet off the ground. If he doesn't give her another push, each swing will be 85% of the previous swing. How would you find the height of the next 3 swings? Use this information to write a formula for the 10th swing. Okay, well, we start out at 5. So the next one, it's going to be 85%. So that would be 5 times 0.85. Okay, so the next one is going to be 85% of that. So I'm going to put a bracket here. 5 times 0.85 times 0.85. Okay, and then the next one would be the first term, 5, times 0.85 times 0.85, that's the third, times 0.85. Okay, and as you can see, we keep repeating things, and we know if we keep repeating, we can use exponents. So what we would find is our term is 5 times 0.85 to the 10 minus 1 power. Why is it minus 1? Because at our first term, we started with the 5. That was our top of our potential. Okay, let's look at page 2. So we're going to find the common ratio here and then find the next term. So this is pretty simple because we're just doing the easy stuff. So 139, we already found the common ratio is multiplied by 3. Well, if I multiply 27 by 3, I get 81. Same thing here. I'm going to multiply 1/2. Half of 10 is 5. Here, I'm going to multiply by 2. 24 times 2 is 48. Okay? So how do we find the next term? Okay? That would be your recursive formula. So how do we find the next term? Find the common ratio by dividing a term in the sequence by its preceding term. Multiply the common ratio to the end. Continue until you have the desired amount of terms. Okay? So we got to find the common ratio. So 324, 108, 36. Okay? What would the common ratio there be? It would be either divide by 3 or multiply by 1/3. Okay? So the common ratio here is multiply by 1/3. What are the next two numbers in the sequence? 1/3 of 36 is 12. 1/3 of 12 is 4. Okay? So you could also find this by just doing 108 over 324 or 36 over 108 and simplifying that. Okay? Same thing here. What is the common ratio? Well, negative 15 over negative 3 or negative 75 over negative 15 is the same as 5. So we know we're going to multiply by 5. So what are the next three numbers? Negative 75 times 5. A negative times a negative, a positive, is a negative 375. Now I take 5 times that. I get negative 1875. And 5 times that, negative 9,375. Okay? And we will cover more recursive formulas in the days to come. So here we're finding the nth term. Remember, when we're finding the nth term, this is explicit. Okay? So, how do I do that? I find the common ratio by dividing a term in the geometric sequence by its preceding term. Substitute your values and find your common ratio. So, each bounce gets lower. Okay? What is my first term? 3. What is my n is the term you're looking for, and r is the common ratio. Okay? So, to find the common ratio, remember, divide. So that would be this term by this term, and that would give me 0.6. Okay? So for this case, I want to find the 9th bounce, so this would be the 9th bounce. Okay? So now I'm going to plug all this information into my explicit formula. Okay? So I'm trying to find the 9th. So you could write a or f of x, it doesn't matter. A to the 9 is equal to, what's your first term? 3 times, what's your common ratio? 0.6 to the, what term are we looking for? 9 minus 1. Oops, I'm sorry. 9 minus 1. So I'm going to make my life easier, and I'm going to use a calculator. So I'm going to get 3 times 0.6 to the 9 minus 1 power. And what am I going to get? I get 0.0503, so we'll just round that to 0.05. Okay, so the ninth term in this, so a, to the ninth is equal to 0.05. All right, let's look at the next one. It continues to grow. So I know my common ratio here is times 2, and it wants the 7th hour. What's my first term? 250. Okay? So write your geometric explicit formula. A to the 7th is equal to the first term times the common ratio to the n minus 1 power. Okay, same thing here. I'm going to use a calculator. 250 times 2 to the 7 minus 1 power. I get 16,000. So, assuming the bacteria grows, in the 7th hour, there will be 16,000 bacteria. Okay? You have 2 to finish, to try on your own, and your teacher will go over them on your next class day. Hope this helped.